Hi there, I'm the CEO of Wander Watts, and I have been working on an alternator attachment for small engines, and I wanted to put it out there and see if anybody would be interested. I want to throw this up on Kickstarter in probably a month or two. This is just a prototype. There are a lot of problems with it, but the idea is if there is a small engine like a weed whacker or just a small engine of some kind, usually handheld devices, you can just slide this on and you can power things that have a car socket or an Anderson socket. And this one is rated up to 50 amps. So theoretically, you can get about 500 watts continuously off of a device like this. Now, this is just a prototype, so there are quite a few problems with it. Mainly the back, which has seen a little bit of melting, as you can probably see. It is not supposed to look like that. And it caused a lot of instability, and the power wasn't able to get up as high as it should have because of that. Future models, I am going to replace it with a piece of aluminum, somewhat like this. I was just working on figuring out a good way to make a urethane mold for this so that I can get consistent, high quality casings. So in designing this, I wanted something that was small but the user could repair, and ideally is really simple. I prefer simplicity if at all possible, and I really wanted this to be something that a lot of people could use if you only have it even for an emergency, or if you just power small electronics when you're camping, or you want something mobile. Personally, I want to put it on an e-bike to power an e-bike around. So that's the idea behind it. Now I was going to talk about some of the design philosophy that goes into making those few things happen. Now the first thing is I want to reduce the number of electronics, and that can be a little tricky, especially if you have an unregulated system. Now, one of the things I wanted to avoid was using something like this. This is amazing. It's called a buck converter, or a buck boost converter is this one. And basically it makes sure that it has a constant voltage output. When you spin a motor, the voltage can vary, usually in a wave format, and the more power you pull, usually the voltage drops. So these are very helpful, but I want to try and avoid it if possible. What that means is I need a motor that can spin at a rate that is fairly constant and will produce roughly 12 volts. If you have things you plug into here, in the car socket or the Anderson connector, then you have something like this, where it can produce about 130 watts. And it has USB connections or just a straight socket, an AC socket. But if you want a little bit more power, this is rated up to 500 watts. And I just have O-ring connections, so this cable I actually got separately, and it just plugs right in. Very simple. However, we need 12 volts because a lot of systems are 12 volt standards. This, for example, is designed for 12 volts, but it'll run from 9 to 15 volts. So that gives us some wiggle room. So I have a few different motor types. Oh, some of them are kind of heavy. I have a few different options here that we're going to look at really fast. Here's 4 of them. First, we want DC power out of these sockets. This is rated for 250 watts. However, there's a couple problems with it. It's pretty big, at least in comparison to something like this. And it can't actually spin that fast because it is a DC motor, therefore it has brushes. And you can't spin those too fast or else they wear out incredibly quick. And even then, their lifespan is shorter, and it is kind of heavy. This was designed for a scooter. So given how slow it goes, this has a rated speed of 2,750 watts. Not bad, but not great either. So if you hook it up to a GX35, those operate best at 5,000 RPM. So you would need to have some gearing. I am really trying to have something mechanically simple. They're a lot easier to work with, both in building and repairs. So we want to avoid something like that. Also, only 250 watts. You want 500 watts, you need something more like this. This is 1,000. This would give you some headroom. But that thing is huge. If you see my design, this one thing is as large as this entire unit. And it's a whole lot heavier. So we need something that can spin a little faster, a little bit more durable. This is an alternator. Now it's a little different than a car alternator. Car alternators can adjust they don't have permanent magnets, so they can adjust their magnetic field so they always maintain 12 volts. They're quite brilliant. This does not have that. This has permanent magnets, so it's a little less reliant on outside electrical systems. This one even came built in with a rectifier. However, still really heavy, and you would probably still want to gear it. Direct gearing with something like this is not easy. So that leaves us with a brushless motor. I could try something like an e-bike, but I found this. It has a 400 kV rating, which means that if you put 1 volt in, it'll turn 400 times a minute. Maybe not the most ideal thing ever, but it's not bad either. So what we want with this is we want to plug it directly into an engine and have it spin so that when the engine gets up to speed, this outputs 12 volts. And 400 kV is just the way to do that, because you get it spinning up to the working RPMs, 5,000, you get 12 volts, which is great. So that's what I have decided to build this whole thing around. Now it's a brushless DC motor, but you don't actually put DC power into it to run it. You put it through a motor controller and it outputs 3-phase AC. Not quite the same thing. So what we need to make this work is something called a rectifier, which I have a very simple one. It's called a bridge rectifier. There are things more efficient than this out there. However, I've chosen to go with this because they are very easy to replace. There are only 5 connection ports. These are everywhere, and it's pretty hefty. It's very durable. And then you just have some wavy voltage, but it's DC. I can smooth it out as I have done. So that is the general idea of how this works. Originally, I started with something a little more like this. Very similar, but it wasn't quite the right size because I messed up a little bit. And originally, it had a bigger motor, but it output a lot higher voltage, and that was a problem. If you have questions about it or recommendations, please let me know. Otherwise, I hope you follow along my journey, and if you're interested, buy one at some point, because I really think this would be a useful product, and I hope you do that. So thank you very much for watching.